And welcome to the channel. Today we are diving into the world of data warehousing and exploring the three main architecture: single tier, two tier and three tier. If you are new to data warehousing or just want a refresher, this is the video for you. Now let us look into the types of warehouse architecture. One is the Let us look into the types of data warehouse architecture. One is the single tier, the other one is the two tier, the last one is the three tier that is widely used. We'll see later in this video why is it widely used. First, let us see the single tier architecture. To explain this, let us consider an example. Example of the shop around your neighborhood, the small shops that you see around your neighborhood. The owner keeps in this shop. What actually happens is the owner keeps all the stocks on the shelves in the same store and serves the customer and does the accounting all in the same room. In single data warehouse, everything happens on one system. As you can see in the image shown here, in single tier architecture, everything happens in this one system. The data stays in its original database, and analysis everything happens using that same system. The problem here, this can slow down things drastically, especially with a lot of users trying to access the things, or when you're like trying to do complex calculation. It's like trying to do accounting while also serving a rush of customers. Things get messy and inefficient. Single tier is rarely used in real-world application due to this performance limitations. Now let us look into the second tier architecture. So to understand it, let's take an example of a bigger shop where you have a separate stock room. The owner keeps the stock in the back and serves the customer in the front. In the same way, we have a copy of original data stored in the database, and the client accesses using its own local computer. So this is better because analyzing the data does not interfere with your day-to-day operations. However, if lots of people need to access the stockroom at the same time, it can get crowded and slow down things, creating a bottleneck. So we use the three-tier architecture, that is most robust and widely used architecture. Why is it widely used? We'll understand it in this. Imagine a well-organized warehouse with three main areas: a storage area, a sorting area, and a packing area, and a delivery area. So what happens here is the bottom tier is also known as the storage area. Data is copied from the original database into the storage area, the data warehouse, and the middle tier area. Then it goes to the sorting and packing area. The OLAP server, where it organizes, summarizes, and prepares the data for analysis. This is where most complex calculation and multi-dimensional analysis happen. And the top tier area, this is where it's finally delivered. So it is also called as delivery area. The front-end tools in an easy to understand format like reports and charts. So what happens is you collect all the data in the bottom tier and you analyze, you do all the calculations and stuff in the middle tier using the OLAP, and finally it is served to customers using the top tier. So this system is the most efficient because each area has a specific job. It can handle large amounts of data and many users without significant performance issues. This is the architecture you'll typically find in enterprise level data warehousing. So for a quick recap, let us go back all the way up here. You see, we learned that single tier, it is very simple but inefficient and rarely used. This is very simple and inefficient and rarely used. And we saw that second tier, two-tier, better separation but can have a bottleneck here and there. And the most important one of them all, the three-tier, the most efficient and scalable, ideal for complex analysis and large database. With this, I would like to wrap the video up. Thanks for watching. If you found this video helpful, please subscribe